Hi, welcome back. Partial differential equations. Lesson number 1. Here we are going to look at successive derivatives. Example number 1. If capital P equal to log e to the base u squared plus v squared, then show that dabba squared p over dabba u squared plus dabba squared p over dabba v squared equal to 0. Here this term is the second successive partial derivative of p with respect to u, and this term is the second successive partial derivative of p with respect to v. Let's see how are we going to tackle this problem. First, it is given p is equal to log e to the base u squared plus v squared, but what we need to find out is the derivative of p with respect to u. So let's see some equations here. One formula is this. Actually, if you have a function fx, if you differentiate fx, and if it is in the numerator and fx in the denominator, if you integrate this function, you get a log e to the base function. So in the same manner, if you differentiate right hand side, you should get a function where it is equal to f dash x divided by fx. Fx is the function inside this logarithmic function. So therefore, if you want to differentiate dp, what we can see is that when you differentiate log function, you get a function f dash x divided by fx. Also, we may have to use this one in this process. That is, the differentiation of a ratio is equal to y dx over dt minus x dy over dt divided by y squared. Let's see how are we going to use these two equations. First, we need to differentiate p with respect to u. P is given, so with respect to u, the partial derivative of capital P with respect to u, and here function fx equal to u squared plus v squared. U squared plus v squared will come here in the denominator, and the numerator is the differential with respect to u, in this case partial differentiation with respect to u of the function fx. In this case, fx equal to u squared plus v squared. We put u squared plus v squared, that means dabba fx divided by dabba u means f dash x, and in this case it's partial derivative, therefore v squared will become a constant. Then when you differentiate u squared with respect to u, it will become 2u. V squared becomes 0 when you differentiate, and the denominator still remains as u squared plus v squared. Now we have a function here which is a ratio. In this case it's like x divided by y, x divided by y. And now we need to differentiate this one again with respect to u. So in this case, we can use this formula here. That means differentiation of dabba p over dabba u with respect to u become dabba squared p over dabba u squared. And then y is equal to u squared plus v squared. So that means y squared equal to u squared plus v squared full squared upon y dx by dt. Y is equal to u squared plus v squared times dabba over dabba u, x equal to 2u minus x 2u times dabba over dabba u dabba y is equal to u squared plus v squared divided by y squared. So when you simplify this one, you get u squared plus v squared times, when you differentiate 2u with respect to u, it will become 2 minus 2u times, when you differentiate u squared plus v squared, partially differentiate with respect to u, then v squared again becomes 0, 2u squared become 2u. So we have a function here 2u squared plus 2v squared minus 4u squared. That means you have 2u squared minus 4u squared become minus 2u squared. So 2u squared will come here and plus 2u v squared come here. So the denominator still remains as u squared plus v squared full square. That is the second successive partial derivative of capital P with respect to u. So that is what we got just now. And we need to find out the second successive partial derivative of capital P with respect to V. So in this case, what you need to do is we just substitute, we interchange the values of u and v. That means instead of u, you can put v to get this one, but this is symmetric, therefore u square plus v square will be as it is, times 2 minus u will become v, u will become v, and denominator will remains as it is because it's symmetric. And then what you get here is 2 times u squared, v will become u squared, minus u will become v squared. Divide by the same denominator. Now we need to find out the given function, which is the addition of the second successive derivative of p with respect to u and second successive derivative of p with respect to v. And first one is from here and the second one is from here, but here we have u squared minus v squared. So you take the negative sign out, we can write it as 2 times v squared minus u squared. So negative time negative will come out. So that means this term and this term will cancel off and you'll end up with a value 0. So basically that's the answer. That means second successive partial derivative of p with respect to u plus second successive partial derivative of p with respect to v is equal to 0. That is the solution to this question.